Welcome to lab number 5, scientific method using the Atwood machine. So you're thinking, what? Wait a minute. Where did this come from? Didn't we already do the Atwood's machine? Yes, we did. So it makes this perfect for this lab. And this also gives you a little bit of a break. You'll be happy to know only if you choose. Will there be any type of Excel file or anything like this? This is sort of a little bit of a break. Now, when we do this in the lab, it's always fun and frustrating. We show a little bit of a video of Apollo 13, missed that, about how they try to fit a square peg into a round hole. Really great movie. If you've never seen it, highly recommend it. So let's move on. Right, so you are also familiar with this setup. It's exactly from that Atwood's machine lab, and an Atwood's machine is it's really interesting. It deals with, if you have balance, then you can set the masses anywhere you want and they work. And people realized that years and years ago, a couple of centuries ago actually, and that's how they were able to bring a window up without the window falling back down. But it required some mechanics of things behind the wall. They had to have counterweights. And if you go into old homes, you'll see that the windows have a piece of cord that goes up along the sides, and then back behind the wall, there is that counterweight that allows you to bring the window up and down, and it stays where you place it. Except over the years, what do you do to a window? Well, it loses its paint. So if you don't strip the paint and you just add paint to it, pretty soon that window gets much heavier than what it would have been because you've added paint layers. So now it doesn't work anymore. Counterweight doesn't balance the weight of the window. Again, it is the whole theory behind the Atwood's machine here, and basically what we do to go about making the Atwood's machine happen. Hope you saw that dirty little secret. I think I have it in one of these slides because that's going to be important. And that dirty little secret was because that cord, the card that's attached to the cord, it doesn't travel up in a nice fashion. It travels up and it is wonky and slow and twisty. And so this lab is notorious for data that just doesn't quite work. So you have to use that dirty little secret. And that involves the equation that you see in the middle of this page. A equals 2y divided by t squared. Now, what assumption are we making with that? We're saying that velocity is constant, or excuse me, 0. Velocity equals 0 when it starts, so there's no initial velocity. But you don't always start that card exactly underneath that photo gate. It's always maybe a centimeter or two below, sloppy, sloppy. And so it has some initial velocity. So now that equation doesn't apply. We'd have to include the term that has the initial velocity of the card. And that's where that dirty little secret comes in. You can see that the procedures are well outlined of what you should do for a proper Atwood's machine lab. And the previous slide showed a video of as good as it can get, at least for us right now, of a proper Atwood's machine lab. The previous slide showed all the data that we got and what we were looking for, and this sort of helps to outline the, oh my, you actually did get a value that wasn't quite right. So now you have a new distance and a new velocity. So estimating the distance below that photo gate, it was probably maybe a centimeter or two. You plop that in and you now have an initial velocity, and that initial velocity is what you use in that corrected experimental value for your acceleration. So this is where, yeah, even in the lab-like setting, when we can meet, we're going to have mistakes, we're going to have errors, and it doesn't quite go the way that we want 100% pure as it's outlined in the lab. And that's sort of what the next slide will be about. All right, now we're to the actual lab that you're going to do. And for this lab, you're going to analyze 4 of the 5 videos listed below. And you're going to create a Google slide presentation or a PowerPoint. You're going to determine where the experimental error occurs in 4 of those 5 videos. How would that affect the results? You're going to address that. And what can the researcher do to adjust the error so that it minimizes the effect on the data? The end product will be a slide presentation, 1 to 2 slides per video. So they are 4 videos, minimum of 4 slides for the meat of the presentation. You should also have a compare and contrast section at the end that would inform the viewer as to the correct methods to utilize when conducting the Atwood's machine lab, and how aspects of each video demonstrate proper lab procedures. So it's a compare and contrast. That's probably going to be a couple of more slides. Don't forget, you should probably have a title page and a reference page. That would be good to have as well. So don't see it right now, but I will include it on the bullet points when you get to see this lab again. So it's fun. It's, a little bit of a take on analysis of labs, and it also gives you a little bit of break from those Excel spreadsheets, gives you a little bit something to do. There will be no lab quiz for this, so this lab in total will be worth 20 points, okay?